Hello, everybody. We have about a little over 10 minutes before we get started, but we want to give everybody an opportunity to make sure that you are connected to audio. So while you are in mute right now, everybody will be muted just because of the number of attendees. You do have to initiate your audio connection, so just make sure that you can hear me and you choose computer or phone audio. Also locate your question feature because you can send chats to us and we will do Q&A at the end. So if you have questions or comments along the way, please feel free to put them in there. I will shoot you all a chat here so that you can respond to that. Otherwise, get a cup of coffee and hang tight, and we'll start at 11 Central Time. As many of you continue to log in, I just want to pop in and say we will start in about 7 minutes. Just check and make sure that your audio is connected. You will remain on mute. Everybody will remain on mute, but you can communicate with us via the chat feature, which many of you have done. So thank you for saying hello. And I love seeing where you're from. So that's awesome. And just make sure that your audio is fully connected so it doesn't do so automatically. You do have to initiate it by choosing computer or phone. So if you can hear me and you're fully connected, just hang tight and we'll start in a few minutes. Okay, everybody, let's just go through, since we're just a couple minutes before 11 when we're going to start, let's just go through and make sure that your audio is connected. So I see a couple of you asked if you should be hearing something. Yes, now you should be hearing something. So hopefully you can. Just make sure that you check your audio. If you're not connected, I did put a message in the chat as well, and I will do that again. Kevin will be taking us through, the productive struggle today, so we're excited for that. But I just wanted to pop in and say something so that those of you who have your audio connected can hear it. And in just a minute, we will go ahead and get started. And yes, the session will be recorded. So I will, at the end of the webinar, I will show you a screenshot of what the certificate looks like when you get it so that everybody is able to easily locate when it's sent. And the certificate actually comes in the same email as the recording. It's sent from the webinar platform as a follow-up. So it will say thank you for attending in the subject line, and then you'll open it up and it will have the recording and then a certificate that you can download and turn in for credit or however you do that. So yes, and I'll show you what that looks like towards the end. So we'll get started in just a minute. Okay, I think we can go ahead and get started. It is 11 o'clock. So good morning, everybody. Thank you so much for joining. I don't know if you all have attended our webinars before, but we are hosting a webinar every Tuesday on different topics. And, these are intended to support you and give you an opportunity to, listen to different presenters go through different topics. So we thank you for coming and hope that you will attend again. I am Kristen Galden. I work with hand2mind. So I am not the one presenting today, but I do want to get everybody started. So again, you are coming in on mute, and this just keeps it easier, no feedback. But you can communicate to us via the question feature. So find that if you have not already. It is what you see on the screen where the purple arrow is at the bottom. We'll sort of flag questions throughout the webinar today. And then towards the end, we will read several of those aloud at the end and let Kevin answer them. And if there are other questions or concerns that come up, Chris and I will address those along the way. So we will keep an eye on that. Before I pass things over to Kevin, I am actually going to do a couple of polls. So let's do this. You can just take a minute to answer these. The first is very basic. So tell me what your role is. Let's see. And for those of you who are having trouble with the audio, just hang tight. I will give you some instructions here. Okay, very good. So let me close this and share. So we have most of you, almost 60% of you are teachers. I have about another 25% that are curriculum coaches or curriculum coordinators. And thank you to those who are answering in the chat. That's perfect. I have one more. This is more about manipulatives in the classroom, in your math. What does that look like? If you are a principal or you are a curriculum coach, answer, what do you recommend? Sort of use that instead of, it may not be you directly delivering the instruction, but how often do you recommend your teachers use them? Oh, good. Look at all those dailies. I love it. Okay. This is great. Look at that. We have 66% use them daily in math. Another 27% use them weekly. So that's amazing. Thank you for weighing in. That just gives us a better idea of, who's in our audience and what your experiences with using manipulatives. So Kevin, I think I am done on my end. So I'm going to go ahead and pass things off to you. Everybody enjoy. This should be great. There he is. So say hi to Kevin.
Well, thanks all. And thanks for joining us and helping me to share two of my passions, using manipulatives as well as using productive struggle. You may recognize, hey, wait a minute, that looks like the inside of a vehicle, and lo and behold, it is. Our internet at school is way faster than my internet at home, and due to our governor's restrictions, we are unable to get into our building, so I'm actually sitting in the parking lot of my school, working from there for a little while. So I want to jump in and I want to dive into using manipulatives and using productive struggle. At the end of the presentation, I'll put my email address back up. And if you want copies of the PowerPoint, you may gladly have copies of that PowerPoint. That is fantastic on my end. So in the chat box, I want you to go ahead and answer this question. What are 3 words that you associate with struggle? Good. All right. So there's lots of different things there. And if you're a typical group, most of them are fairly negative in nature. And most of us don't associate positive things with struggle. And I want to try to change our mindset a little bit this morning or this afternoon or this evening, whenever it is that you are watching. So I want you to think about when you learn to ride a bike. Look at the sheer joy on there. And we know that there's struggle involved with learning to ride a bike. Think about when you learn to ride or drive a car, or more terrifyingly, if you've been the parent who's tried to help a child learn to drive a car. We know there's a ton of struggle involved with there. I vividly remember when my older daughter was taking driver's training and she came out of her class and said, "Dad, I can drive home today." And I said, "No, you can't, because I'm not mentally prepared for that. I need to have a little bit more advanced notice that you're going to carry my life in your hands." She looked at me and said, "Quit being dramatic, Dad," and hopped in the driver's seat, and it was terrifying. The curves were not nearly as smooth as what they should have been, but lo and behold, after some struggle, she ended up becoming a very, very good driver. So I think often in the non-education setting, we value struggle. But when we get to education, all of a sudden the struggle is no longer valued. And I want to help us to start shifting our minds about that a little bit. So the National Council of Teachers of Mathematics has a wonderful document called Principles to Action. And as part of it, they talk about productive struggle. And there you see that we're concerned about more than just simply getting correct answers. We want them to delve into that understanding. We want them to have some clue as to what's going on and not just be a rule memorizer. In a book that was just released last month, my 2 co-authors, John Sangiovanni from Maryland, Susie Cott from Nebraska, and I, in our book, we talk about productive struggle, and we say, it's our experience as students, we don't learn how to facilitate the struggle. Our teacher prep didn't prepare us. And in fact, for many of us in our teacher prep, we were told to try to avoid struggle at all costs. And when I started teaching, I tried to avoid having my students struggle. I tried to have the most thoughtfully designed lessons, and I realized I was doing way more work than what they were doing, and I started to become very, very frustrated with myself at times. A lot of times we think that struggle is unpredictable. It's sort of in the moment. We don't realize, oh, there's a lot we can do to actually plan for that. There's a lot of things we can do to support that. And using manipulatives is a fantastic way to help support that struggle. And believing in growth mindset is a great start, but that's not the same as truly appreciating struggle. So in our time this morning or this afternoon or the evening, depending on when you are watching this session, I want to talk about 6 different actions to help us provoke some productive struggle and look at how manipulatives play such a vital role in provoking that productive struggle. So we're going to go through each of those 6 actions real briefly. I'll share a few different ideas related around each one of them. So this first action is to value productive struggle. So we know that struggle is a necessary component. It leads to long-term benefits. There's a lot of research out there that says, yes, this is stuff that we should be doing, and we just don't often do it. Getting math needs to be more than just procedural understanding. For many of us, we grew up in a time where procedures were all that really mattered. I was a great rule memorizer. And that's why I became a math teacher, because I had those rules memorized. I had no clue what most of those rules were really telling us. It wasn't until I started teaching that I finally got to that understanding, that good conceptual understanding. And we know that if we can give them some of those non-math skills, if we can get them to truly value persevering through productive struggle, that's going to be an essential life skill for them later on. We know that the US math instruction is often criticized as not asking some of those deep questions, that we just like to, here's the answer, is it right, is it wrong, and then we move on. We often perceive frustration as failing on the teacher's end. And then we just throw out the little rescue ring and we try to help them. And our kids, especially by the time they get to later elementary, middle school, and high school, they know if they sit and stare blankly long enough that their teacher's going to come quickly rushing over there, and being the nurturing selves, we're going to try to rescue them and try to help them with everything. So I want to share a flashback a minute to my elementary grades. And when I was in elementary school, I know I learned how to multiply two-digit numbers. And it was something like this. 3 times 8 is 24. You write a 4 and a little 2. To this day, I have no idea why it had to be a little 2, and our little 2 had to be above and to the left of the 7. Then 8 times 7 is 56, plus the little 2 is 58, and this time, it's okay to write that 2-digit number. The first time when I got 24, I couldn't write a 2-digit number. The second time, I can write it as a 2-digit number. Put a 0. Teacher, why do you put a 0 there? Because you do. 3 times 2 is 6. 2 times 7 is 14. Then we add them up. 4 plus 0 is 4. 8 plus 6 is 14. Put a little 1 there. 1 plus 5 plus 4 is 10. Put another little 1 there, and we get 2044. Those of us that memorized it well the first day were bored the next 2 weeks when we practiced it over and over and over again. Those of us that didn't memorize it well the first day were probably still bored as we practiced for 2 straight weeks just memorizing this procedure. There is a time and a place for that standard algorithm, but I want my students to develop a rich, deep understanding. So do we value our students struggling enough to move away from just memorizing a set of procedures and helping them try to use some sort of a manipulative for that? So I want to share, maybe we'll do 12 times 13, something a little bit smaller. I don't want to do that large of a number, because then our time gets spent, can we move all the manipulatives to all of the right spots? So I'm going to start here with my 12 times 13. Oops. And there's my factor of 12. Here comes my factor of 13 in just a moment. And then the student's job is going to be to fill in that rectangle. So we have our 2 factors. They start to fill in the rectangle. The first time it's painful to watch them place all those pieces in there, because they don't know what pieces are going to go in there. I do, so I'm going to speed it up a little bit there. And they can figure out, oh, there's my picture of what it's going to look like. I, as a teacher then, I often do a quick little drawing of what that model is going to look like. Notice I haven't started to tell them, here's how you multiply two-digit numbers. They come up with that. I do a quick little sketch then and say, oh, here's our answer. It looks something like this. It doesn't take the students tremendously long, and when we look at our 12 times 13, it doesn't take them long, and they start to recognize that no matter how we did it, there's 4 different sections. There's a section of all of our units together. There's a section where we have some of our longs horizontal or vertical. There's a section where we have some of our longs horizontal. There's a section where all of our flats are together. And once I can get them to this point, all of a sudden we can start moving and saying, all right, how did we get this section there? That's our 2 times 3, that was 6. How did we get this second section? Well, that was a factor of 3 multiplied by the factor of 10. That 3 times 10 gave us 30. So we're up to 36 there. How did I get this section down there? That's my 10 by the 2, so that's 20. There's my 10 by 10, so that's 100. Add them up and we get our 156. This is that partial products algorithm. This is that algorithm that makes so much mathematical sense. Our students love it until they bring it home and the parents say, this is the dumbest thing I've ever heard in my life. Why don't you just do it my normal way? I think the standard algorithm is really that partial products as a shortcut. So our students know 3 times 2 is 6, 3 times 10 is 30, but they can add 30 and 6 right away and make it 36. Instead of just putting down that 0, we could do 10 times 2, that's 20. 10 times 10 is 100. Add it right away to that 120 so that standard algorithm is really that partial products just combined a little bit to get to that there. And all of a sudden, we're showing that we value that struggle. We're not jumping right to here's a memorization. We want our students to have some sort of understanding of what's going on. The same thing can happen when we want to look at adding integers. When we want to add integers, many of us just memorized a set of different rules. Something like if the signs are different, subtract the absolute values of both numbers, choose the one that has the greater absolute value. I want to look at adding integers, and I value productive struggle enough that I want my students to make some sense. I want my students to start to figure out what's going on. So maybe I'll use some 2-color counters or algebra tiles or something. There's a 5 plus a negative 2. I have positive 5, 2 negatives on there. I can make those 0 pairs, draw a picture if I wanted to, and our 5 plus negative 2 becomes a 3. And all of a sudden, my students are starting to be able to make some connections. Now, I have to caution myself all the time that I don't want my students using the manipulatives to do the math. I want them to do it to learn that math. But I value that productive struggle enough that I know that just telling them, here's how you do it, is not going to be good enough. We need to be able to develop that good conceptual understanding. So with both of those, I try to sort of briefly illustrate that when we use manipulatives, there's really a 3-step progress. We're moving from the concrete stage where they're using that physical manipulative to the pictorial stage or representational or semi-concrete. There's lots of different terms for that middle stage there where they're drawing some sort of sketch. And finally getting to that abstract stage. And by abstract, I don't mean difficult. I mean, at the end of the day, if my students can only multiply 2 two-digit numbers by grabbing base 10 blocks, that's a problem. Or if they can only add integers by grabbing 2-color counters, that's an issue. So there's that first pillar, that first step in the supporting productive struggle, that valuing it. And teachers really need to value that productive struggle in order for us to be able to effectively use it in our classroom. A second action is to foster the student's identity as mathematics learners. So math identity is really that disposition and the deeply held belief that each and every student is able to participate and perform effectively in mathematics. And I often wonder, what identity do my students have? Do they view themselves as math learners, or do they view themselves as somebody who's unable to do math? And I want them to all recognize that through supporting it, through using manipulatives, through using other things, they're able to come out and really get a good, rich, deep math identity. So one of the activities I'd like to do with my students throughout the year, I just say, I want you to create an emoji. Think about for when you think about math, or create an emoji for when you've overcame a challenge, or think about an emoji for when you'd rather be doing something other than math, an emoji for when you're proud of yourself in math. Now, most times I don't give them all 8 different prompts. I may give them 1 or 2 different prompts and have them draw an emoji. And I gain so much more from their little bit of drawing an emoji than I would if I asked them to write a paragraph or write a couple of sentences. It's a different way. It starts to help me see who they are as a learner, and I can continue to build off of that then. So there, and I know you can't see the pictures tremendously, and the words are faded a little bit, but then the one on the far left, on the left hand side, it's when they overcame a challenge. On the right hand side, where it looks like they're sweating profusely, the words there say, "When I am struggling." When they're challenged, is that top on the right. When you are struggling is right next to it. On the bottom right, on the left-hand side, when I think about math, and the other one's when I am being challenged. So there's so much information that we can gain to help us start to get an idea of what is their identity at that point in time. A third action is to build community. And classroom community is such an important thing. And we need to have a good supportive classroom if we're truly interested in helping our students with that productive math struggle. I know as a starting teacher, I didn't value this nearly enough. I thought, I'm going to go in there, start teaching math, and we'll go from there. And the longer that I teach, the more I realize we really need to do a lot of work with helping our students build community. Building community is not something just at the beginning of the year. It's one of those things that needs to be continually built throughout the year and continually maintained. I was talking with a colleague yesterday, I think, and we both commented, we wonder how this COVID-19 crisis, how all this remote learning would have worked if it was at the beginning of the school year. And come the fall, we may be able to experience what it looks like to do remote learning at the beginning of the school year. We're not sure yet, but we've had 6 months, 7 months, whatever, that we've built that community within our classrooms. We've built that identity with our students. We've built those relationships, and now we can go through this period of remote learning, building off of those relationships that we've established, building off of that community that we've developed with each of our students in each of our classrooms. So we know that we have to continually build it throughout that school year. Community has to have some norms for productive struggle. What does it look like to support each other? It can't be if I'm the first student done that I just start helping all of my classmates, and by helping, I use that very, very loosely, helping them by saying, here's what you need to do. I need to instead, as a student, I need to have some questions that I can ask other classmates then. So I have 9 pictures here that are different things that you could use as a metaphor for struggle. Which one of those resonates most with you and why? So I'll give you a moment to go ahead in that chat room. I'll give you about 30 seconds or so. Which one of those is which one resonates best with you and why? I'll give you another 15 seconds or so. So I know for myself, at any given time, I may be experiencing any one of these different 9. And as I progress throughout a school year, throughout a day, throughout a class period, throughout a remote learning experience, I may feel different ones of these at different times. The one that I want to talk about just briefly is this one here, this mountain climber. The thing that strikes me with this mountain climber is he has the right tools. And I look at using manipulatives as a tool. Sometimes we need to have that right tool in order to be able to truly help our students and to have that good community in our classroom. We need to have access to the appropriate tools. So one of the tools, let me go back to here, Matt, is this 25, oops, is the 25 plus 17. I want to have it from the appropriate tools there. I could just teach them how to do that, but I want to have them use those base 10 blocks and develop an understanding of adding two-digit numbers. So you can see there I have a 25, and then I added 17 more. I can do a little bit of clicking and dragging, and I end up getting my answer then of 42, where they're starting to make that idea of regrouping with the tens, rather than me just saying, here is what you need to do. The same idea happens when we're adding fractions. And let me jump back to my manipulatives for this. So one of the things I want to point out, if you're interested in the manipulatives, and since I forget to say it, so I'm going to say it right off the bat now before I forget, if you go to hand2mind.com and then /braining-camp, all one word there, you can find out more information about these virtual manipulatives. And I really like the ones through hand2mind and braining-camp because all the colors match up then with the physical manipulatives. It's not that there's different color schemes for different ones. So if I'm looking at building community and sharing that value of we need to have the right tool for it, if I want to look at the problem 1/4 plus 2/4, there's my 1/4, there's 2/4. It's fairly evident for the students to see once why 1/4 plus 2/4 is 3/4. I'm not telling them, here's how you're doing it. They're developing a sense, they're developing that community because they're recognizing it's okay, it's valuable for us to have our manipulatives out. Very similarly then, I need to have the right tools in my community when I want to look at 1/2 plus 1/4. If I look at 1/2 plus 1/4, my students can quickly recognize, oh, those pieces are different. I don't have two somethings. Here, all my pieces were the same, so I just had 3 of those 1/4 pieces or 3/4. Here, I don't have it. So I don't get that answer of 2/6 nearly as often as we have with other things. So some of my students will go through then and they'll switch that problem, and the 1/2 plus 1/4 will all of a sudden become 2/4 plus 1/4, and they get that answer of 3/4. Others of my students may all of a sudden go and start changing it and changing it all to eighths. And they have changed that problem then to 4/8 plus 2/8. It still gives us that same answer of 6/8. So again, we need to look at that classroom climate, that classroom community, and we need to develop a sense that it's good to be using manipulatives, and that's going to help us learn. Even for that rule memorizer, and I shared at the beginning, I was a great rule memorizer. I don't think I understood. In fact, I know I didn't understand much of what I was doing. I just did a great job of memorizing that. And I want when my students pass that memorizing, I want to get them to that understanding. And manipulatives is such a valuable tool to help build that classroom culture that it's okay to struggle. It's okay then that we need to work through things. A fourth action that we can take in supporting productive math struggle is planning for that struggle. It's not just a willy-nilly thing. It's not, oh, yeah, they're going to struggle somewhere in there and I don't know what to do until they start struggling. We need to be thinking ahead of time, what types of things can we do to help support that struggle? And part of that planning for the struggle is ensuring that struggle does happen. If we give them low-level tasks, low-level direct problems, we may not get the same type of struggle as what we get if we change some of our problems. So on the left-hand side here, in this task C, you see a task where it just tells the students count the total number of small blocks. Not a wonderful task there. I can change things up there and really use it with manipulatives. Ask them make 37 in 3 different ways. Tell how they all are showing 37. So I can take what may be a fairly routine task on the left and make it one where they're going to have a lot more struggle, where they're going to get through that struggle, they're going to get a much deeper understanding. Maybe I want to look at something with some sort of a generalizing. Max says 3 plus 5 is the same as 5 plus 3. Does this always work? And I know when I was in school, we were just told, yep, it works. It's a commutative property of addition. Trust the teacher, trust the book. I want my students to develop a good understanding. So in an elementary classroom, what about this? Is this helping to answer this question, does it always work? Can I use my manipulatives to start making some of those arguments of, yeah, 3 plus 5 and 5 plus 3 are the exact same thing? And I think that when we use our manipulatives, we can get so many other ways of explaining our reasoning. It gives our students another chance, another way that they can demonstrate that good, solid understanding. Another one, On the left-hand side here, we see a fairly standard textbook type of worksheet problem where it asks them to write the tens and write the ones, and they give them a variety of different ones. We could instead give them some pictorial representations. There on the right, you see 4 of them. Ask them, how are they the same? How are they all different? What are you noticing about that? And all of a sudden, we're using our manipulatives in a different way. We're not using it just as a straightforward find an answer. We want them to be able to compare, contrast, look at the different things with our manipulatives. Sometimes I think, oh, there's a lot of those, find the perimeter, find that distance around a complex type of a figure. This is obviously more of a middle school picture, but I want to share an example of one that we could do already in the elementary grades, early elementary, and it's called ant walks. Now, I will say in my middle school, I do modify this slightly to hit a middle school type of a concept, but I want to share a sort of a K2 example with this. So an ant is training for the ant Olympics. We want to know how many ant walks of different lengths can we design for it to train on. So we're going to use 2 red, 2 blue, 2 yellow pattern blocks. The students are going to create an ant walk that uses all of those blocks. I'll remind the students that a full side needs to touch a full side. They're going to trace that ant walk on paper, and then they're going to find that distance around the outside. So let me jump back to my manipulatives again and jump to my pattern blocks. And I think we said to use 2 of our yellow hexagons, 2 of our red trapezoids, and 2 of our blue parallelograms. Now, I will say one of the things I have found when I'm using my manipulatives and my pattern blocks, I have to identify them initially by color and by name. If I tell my students grab 2 trapezoids, the 3 students that remember what a trapezoid are, they're in great shape. The rest of them have checked out because they've completely and totally forgotten about what the shapes are, and they think that they're clueless as to what to do. So I tell them you need to make some sort of a pattern. Connecting pieces just at a corner isn't allowed. Connecting pieces mid-side to mid-side isn't allowed. But I tell my students this is allowed, even though it's a corner to corner for the trapezoid and the hexagon, we have this parallelogram in the middle that works. This also is fine. It's not a full side to a full side because that trapezoid has a slightly different size than the other ones. So the students make some sort of a figure with that. They can take a green piece if needed, and they can count that distance around the outside. 1, 2, 3, move all the way around. So let me jump back to my PowerPoint because I made one up ahead of time with the answer in there to help speed things along so you don't sit and watch me click and drag the entire time. So there's a different shape. They found that distance is 20. So in a kindergarten's first, second grade classroom, ask them to make a variety of different ones. And then we know we need to do something mathematical with it. So maybe I ask the students, how are all your ant walks the same? How are they different? Or I have one of them hold up one of their ant walks and ask the students, does anybody have one that's shorter? Anybody have one that's longer? That third question, maybe I ask them which one should they use to train for the Ant Olympics. There is no right answer there, but it's getting to that why. And I think the more often we can get our students to that why stage and have them start to justify their reasoning, the better we're going to be later on. Another example, we can do what is the fraction of that shaded part. And we've all done lots of problems very similar to that as students. We may have done them as teachers as well. And there may be a time and a place to give them just that. But I want to compare that, contrast that to this. What if I go back to my pattern blocks and I say that yellow hexagon has a value of 1. And then I ask them, what's the value of a trapezoid? What's the value of a rhombus? What's the value of a green triangle? So let me go back to my pattern blocks and let me demonstrate what I'm trying to say here. So I'm going to say that one has a value of 1, and then we're going to ask for the values of those other pieces. So if this has a value of 1, I want you to go ahead in the chat box and enter what you think the value of the red trapezoid is. Now, if you've never used pattern blocks before, it may be harder just to eyeball it and many of us have used pattern blocks before, so we have some understanding. Good, and I see a lot of 1/2s. And most people recognize, oh, if I put 2 of the trapezoids right on top of there, I can get that, and we're all set. We can see those 2 trapezoids fill up one of those hexagons. I could do similar things then with those other 2 shapes. My parallelogram has a value of a third. The green triangle has a value of a sixth. But then all of a sudden, I'm going to switch it with my students. And I say, all right, now this one has a value of 1, that trapezoid. If that has a value of 1, what's the value of that green triangle? And they recognize that's 1/3. And then I play stupid and say, wait a minute, you just told me that triangle had a value of 1/6. Now you're telling me the triangle has a value of 1/3. And we're starting to really hone in on that idea that a fraction is part of a whole. And I don't think we fully get that same notion when I do just here's the same size circle every single time. You have to fill in that shaded bit. You figure out a fraction. I think we get a much deeper understanding when we do something like that in that example that is modified. We can also switch it up a little bit and say, oh, the hexagon has a value of 3/4. What does 1 look like? So I tell them, there's my model of 3/4. You go through and figure out what is the 1 going to look like. And it takes the students some time to figure it out, but eventually they start to recognize, oh, 3/4 means I have 3 pieces, or 3 of the 4 equally sized pieces. So I need to divide that into 3 equal sized pieces, which the parallelograms, and then add 1 more. So now I have 3 that make a hexagon out of the 4 total. So something that looks like that. And I think in the PowerPoint, I know I put answers to all of these different types of ones so that when you look at them later on, you remember, oh, here's what he did at that point in time. And there I shared it. I combined those parallelograms to make it back into that hexagon to make it match up a little bit with there. Or I could even, if I want to keep going on that same vein, give them a riddle and tell them all of the pieces in my box, my bag, my container, my whatever is the same as the area of 24 green triangles. 3 of those blocks are making up 75% of the area. The green blocks cover half as much area as the blue blocks. So in the class, I'd give them some time to work on that, and they come up with their answer. Now, I was in Texas a couple of summers ago, and this is one of the answers that I ended up getting in one of those groups. And this one caused some debate. So you notice the third clue was the green blocks cover half as much area as the blue blocks. This person's colleagues didn't like that solution because they said there's no blue, there's no green. So the person said, all right, what's my area of the blue? And they said 0. What's half of 0? 0. Therefore, 0 is half of 0. This solution is right. This is the solution that most people end up coming with, but I loved the solution there because they were able to justify their thinking. And so often when I'm using manipulatives, it's giving my students, along with a rich, deep task, it's giving my students another way to be able to express their understanding, another way to show that they're not just memorizing, that they're getting a good conceptual understanding. So when I look at, hey, I need to plan my lessons, I spend some time ahead of time, and I really, after I've done that task and done that task, I anticipate what strategies my students are going to do. And then along with that, I anticipate what misconceptions are they going to have, both correct solutions and some of those sort of those incorrect, those false things. And I know that if I do some of that stuff ahead of time, when I'm in the moment with my students, the questions that I ask, the support that I give them are much better. So as I'm planning, I also plan out those reactions. I plan what might I ask for that student who has this misconception, this partial understanding. What question might I ask to somebody who's doing it correctly to push their thinking a little bit? That fifth one then really ties in nicely with the planning stage. So that fifth action is to support that struggle. And we know that there's struggle involved with learning things. We know that our students are going to have some struggle with that. Why do students struggle? And I think so often we say, oh, my student is struggling. I think there's so many different types of struggle, and it's helpful to identify what type of struggle are they having. Are they just not able to get started? Is it that they don't know how to do a calculation? That the numbers that we provided are a little messier, so to speak, than what they're willing to mess with at that point in time? Are they unable to explain? So often we make this blanket statement, my student's struggling. I want to encourage us to really look at where are they struggling. And I will say with that first one, with the unable to get started, I have found that when I use my manipulatives, my students get started. It provides a nice entry point into the learning for that day. They're so much more engaged than when I do a lesson without those manipulatives. Our responses then, we also need to think about our responses. Are we rescuing the answers, or are we rescuing their thinking? We need to be thinking about what types of things are we doing? Are we just telling them the answer? Are we saying, oh, nice try, keep working hard and move away? Or do we provide some ways to really honor their thinking and give them some stuff? And we have to be careful that we're not just asking all these yes, no questions where they just learn to say yes and nod their heads, and then we walk away and they turn to their neighbor and say, I have no clue what I just did, but I got the right answer because we've done all the thinking. We really want to rescue their thinking and really help them recognize, where were you starting to think? Let's pull those manipulatives, or let's really start to develop some understanding there. So I want to illustrate this with an activity that I like to do with my middle school students. And you can adapt it for elementary grades, you can adapt it for high school grades. It's called growing rectangles. So we're going to make a rectangle that's 1 tile long by 2 tiles wide, record how many tiles were used, add a tile to each one of our sides. So I did the first couple of them ahead of time. I made my 1 by 2 there in the red. So figure number 1 used 2 color tiles. The second one then in the blue is a 2 by 3. It used 6. So I give my students some time, tell them I want you to build until you think you found some sort of a pattern, and I have them usually do the table for 3, 4, 5, 6, and then jump to 10. Sometimes maybe jump to 100 if I really want to push their thinking. Depending on the grade level, maybe I have them try to find for that nth term. So here are 2 different groups that I had that did that. One of the groups just kept making with a table, 3 with 12, 4 with 20, on and on. They noticed that for the first one, to jump from 2 to 6, you added 4. To jump from 6 to 12, you added 6. To get from 12 to 20, you added 8, added 10, added 12. So they continued with that table, added 14, 16, 18, and 20, and they got that the 10th one gave us 110. The same class, different group, same table. Notice the first 6 are identical, but they said they noticed that the first rectangle was a 1 by 2, then a 2 by 3, a 3 by 4. So the 10th one is going to be 10 times 11, or 110. Same answer, drastically different ways. And we're using it with those manipulatives. If I would have just said, build that table, my students would have been a lot less likely to build that table. So that I know that there's a variety of different strategies. I'm thinking ahead of time, how can I support those different groups? How can I move them forward in their thinking? One of the things that I've discovered when I've been using manipulatives and giving them some of those tasks, I call it a catch and release. And we talk more about this in our book. For many of us, we have sort of that launch, explore, summarize type of a mindset, that we get them started, they do all this work, and then we try to summarize at the end. Sometimes at the end, it's way too late. I started to realize, oh, if I'm catching that they're all making very similar mistakes, I'm going to stop them at one point in time, get their attention back, and then I'm going to release them all after we've had a conversation. So sometimes it looks like sort of like a launch, explore, summarize, explore, summarize, explore, summarize. There may be several times throughout that lesson that I'm catching and releasing them, because as they're working, as they're engaging, as they're struggling, there are some things that are better that I can have all of the groups share out with each other and not wait until the end of that lesson to have that little bit of summary. And then that 6th and final action that I think there is in supporting productive math struggle is reflecting. And this is the stage that I think we just don't do enough of. When we look at our exit tickets, it's usually all conceptual in nature. Do they understand the concept? Are they able to do that procedural? We often don't ask them to do some sort of reflecting on, hey, were you able to persevere through that productive struggle of the day? So one of them that I like to do, I like to give my students all a sticky note and then just say, I want you to write down one word to best describe math today. Sometimes it may be something they asked, a question when they weren't sure what to do. Maybe somebody writes compared and they were thinking my thinking to somebody else's thinking. Or somebody writes poster. They use the class struggle poster to find some ways to get unstuck. And I get so much just great information from my students when I ask them to just give me one word about math today, rather than the normal, were you able to do this as an exit ticket? Maybe we think of doing something like this as an exit ticket. I also like to celebrate the struggle. Now, I'll confess I don't do these with my middle school students, but I know there are elementary teachers that do that within the supporting. The little shout out, then the teacher gives a little shout out to somebody for whatever reason they saw with that struggle, how they persevere through that struggle, or how they saw another student supporting another student with that struggle and really helping them with that. Give them a struggle buck. Congratulations, I saw you're really struggling and persevering through that and not getting frustrated, not giving up, not throwing your pencil down, not bursting into tears. Here's a struggle buck. And then occasionally you have an option for them to go to the struggle store or whatever you want to call it, and they can cash in some of their struggle dollars and get a little token response. So again, there are those 6 actions that I think that we can use to support productive math struggle. The valuing the struggle. Do we really value using manipulatives in there? And I think the answer needs to be yes. We need to value manipulatives as a tool to support that productive struggle. We need to foster those students' identity to see them as good, rich, deep math problem solvers, as good mathematicians. And I think using manipulatives really helps with that fostering stage. We need to build that classroom community where it's supportive of using a variety of different manipulatives, and recognizing that while I may not need a manipulative for this, a lot of my classmates may need that. And even though if I memorized it, in fact, I probably still need it to help me fully understand that. There's that stage where the planning, we need to plan for that struggle. We need to find good, rich, deep math tasks that we can use to help build that math struggle. We need to support it. And finally, we need to reflect on that. So I want to share a couple of solutions from hand to mind that I think do a great job of supporting that productive struggle and showing us how to use some manipulatives. The first one is hands-on standards, and I just pulled a screenshot of one from a middle school. It's a kindergarten through 8th grade. Each grade is its own book, and all of them have that same sort of picture by picture, step by step. Here is what it's going to look like. There's the covers of a variety of them. They come in a Common Core edition for Common Core states. They come in a non-Common Core edition as well. A second resource that I think does a fantastic job of showing how to use manipulatives and really building some productive struggle is a resource called Math Tasks. Math Tasks is grade banded. There's a K2 grade band, a 3-5, and then a 6-8. And again, all the lessons are set up the same. There's a little overview, a big idea where they sort of talk about the mathematics in there. And then there's a 4-step little with the teaching, a way to introduce it, a way to do the problem on their own, and that time for those small groups of working, some ideas to generate some conversation in that math talk, and finally in the extension. On the right there, you see the on their own. This is the student-facing material designed as a black line master where the students can have it there. They're also available as table tents. The math tasks I shared are available in those 3 different grade bands. You can buy an individual book, you can buy a library, you can buy a classroom bundle that has the manipulatives, doesn't have the manipulatives. For our elementary friends, right now, another great resource that's a brand new one, there's some take-home manipulative kits where there's a K2 version and a 3-5 where there's some manipulatives in there as well as some lessons involved with there. And then I also want to share there's hand to mind at home for in this time if we're a K5 teacher and we're looking for what can my students be doing manipulative based, there's a great resource there. And last week's webinar focused on that, but you can go to hand to mind at home. There are free lessons available there for several months worth of stuff in the math area, STEM area, and the literacy area. So again, those four resources, the hands-on standards, the math tasks, those take-home manipulative kits, teach at home. I've also put my email address there. If you want copies of that PowerPoint or you have questions in general about how to use manipulatives, please feel free to reach out to me, and I am happy to email you that. If you want the PowerPoint, if you just tell me the productive struggle PowerPoint, that's enough information, and I'll know to send you that PowerPoint out at that point. So we're going to turn over some questions and answers. So this is when Kristen or Chris are going to jump back in and share those questions, and I'll do my best to answer them.
Yes, thank you. That was great, Kevin. And I'm actually, while we're doing that, I'm going to go ahead and take the screen as well. So let me go ahead and just ask the first question here. You guys were so good. It's so hard to keep up with the chat when it's going so fast. Lots of good questions. So one of the questions about Braining Camp, and I feel like I remember this, but I could be mistaken. Can students snap a photo of their work and submit it? How does that work?
Yeah, I would think that they could easily snap a picture of that. And, when I do it with a PowerPoint, I just took some screenshots of it to put into the PowerPoint to make it convenient for attendees later on as they're going back and looking at it. So yeah, students have access. I think they can take a quick little screenshot of it and go from there. Or they could take a picture with their phone, but sometimes it's just easy to do a screenshot.
Okay, not like a camera embedded into Braining Camp that they can click.
Not that I have found yet,
okay.
No.
Okay. When you have students do exit tickets, do you have them put their name on it?
Depends. Sometimes yes, sometimes no. It depends on where I'm going from that. If I'm doing more of the procedural type of ones, absolutely. If I'm doing more one of those one word to describe it, no, I don't want their names on there. I give it as an optional thing. Sometimes I do, but if I'm looking for the real honest answers from there, I don't want them to think that there's going to be some sort of judgment associated with that. So when I do some of those more, how was the struggle go for you today? Those are usually anonymous. Now, having said that, I still have 25% of my kids who still write their name on that. Either they don't listen or they don't really care if I know who it was. But no, I usually, when it's those more productive struggle type of closures, I don't have them put their names on it.
Okay. What about, how do you help students who get anxious when dealing with struggle to keep them from being in sort of stress response mode?
Yeah, that's a great question. And that really comes back to that building that classroom culture, building that student's identity and helping them with that. As a teacher, you know your students, you know which ones of those have a sort of a short fuse and which ones have a little bit longer fuse. So I know which of my students I need to do a better job of touching base with a little more frequently than with other students. And sometimes it's more of a proactive. If I know that Alex is going to be the one that's going to struggle right off the bat and have an explosive reaction to it, as soon as they're working on that task, I'm going to go over to Alex's group and I'm going to sit right there and sort of do some preemptive work with Alex's group. And it's building those relationships, and it takes time. And it's that developing that fine sense of how much struggle is too much struggle, but yet giving them the time so that it's not too little of struggle. So it's not really a give them this much time. It's really, you need to know your learners, and some days work better than others, and sometimes there's some alternative. I mean, so often there's other familial factors going on that you just don't know. If they were running late in the morning, that may have set them off. If they ran out of the favorite cereal in the morning, it may have set them off. If all of a sudden mom or dad are at risk of losing their job, that may set them off. So there's so many other things. So it's really identifying, do you know your kids? What can I do to support them? All those good things we would do, and really watch for when you start to see a struggle start to become more than productive, that it starts to become a destructive struggle.
That's perfect. Some great feedback, by the way, on your presentation today. So well done, Kevin. It was a hit. So actually, I think the only other question I'm going to address was, how do you propose we supply students with the manipulatives? And I honestly am going to go back just a moment to the take-home manipulative kits, because while this is not about showing you a product, these webinars are intended to give you instructional support. That's the exact reason that we developed these. So, we want students to have access to the tools that they use to learn, particularly for math. The hands-on and engagement is really important, and it's hard for them to do that at home. Yes, they can use things like Legos, or you could do counting with Barbie shoes if you had to, but it's nice for them to have the manipulatives that they're used to using in school. So we do have a K2 and a 3-5, and the great thing about these kits is they're cost effective. So they're only I want to say they're $24.99 with no discounts. And they come with an activity guide, and the activity guide shows whoever's looking at it, whether that be a parent or a teacher, how to use the manipulative, and then it gives you 2 activities, like suggested activities. So it's not just the tools, it also gives them the information for how to use them. So that would be my answer to that question. I'm going to put a Padlet link in the chat box, and you guys will see it pop up where you've seen all the others. So I want you guys to, let me try this again. I would like you all to respond to the question that I have up here. So it's just going to be Padlet.com. Just get rid of this. Padlet.com. It should look like this when you click on it. So it's supporting productive struggle in math. I would like you to just double click anywhere on the Padlet and tell us what your favorite manipulative is to use in math. So if you can locate the link, while you all are doing that, I would also like to announce that Susan Lee is our winner today. So every Tuesday when we have these webinars, we actually give away one of our products, and today it is math tasks. So Susan, yay, you can choose from any of these bundles. We have Cuisenaire rods, pattern blocks, color tiles, snap cubes, base 10 blocks, and geoboards. So I'll send you a follow-up email, and we can get that, we can get the specifics dealt with there. And then the other thing I want to show you before I go back to the Padlet is that this is what your follow-up email will look like. So I think I have it set for 3 hours after the event. So later this afternoon, you will get an email from GoTo. It actually may look like it's coming from me. And it says, again, thank you for attending this webinar. In the body of that email, it says recording and certificate. So you can see there I have circled certificate. That is a PDF that you can click and open and download, and it will just say, whatever. It'll just say your name, the webinar, I think the date. And then if you click the watch recording, that will be the for today. So you can go in and watch that as many times as you want to. So this was great. You guys have put great feedback in the chat box. So again, thank you, Kevin. Great job. Thanks for, a great webinar. We look forward to another one. We are doing these every Tuesday, so feel free to join. Next Tuesday will be Makerspace. So we hope everybody has a good rest of the week.
Thanks for coming.